Alright, hello everybody. Thank you for coming today. This is my Capstone project presentation for my active aero wing. And before we get into it, just a little bit about me. I'm a senior here at Grandview. I have been in engineering courses for quite some time now. I took my very first one way back in 6th grade, and I've been in them ever since. I've taken 3 years of engineering here at Grandview, this being my final year. And with that, I am CSW PA certified, which is a professional certification for an industry-grade 3D modeling software called SolidWorks. And then in the fall of this year, I will be attending the Colorado School of Mines to major in mechanical engineering. And so, just real quick, a quick overview of what an active aero wing is. Basically, it's like any generic wing. It's used to improve the performance of a car, except with an active aero wing, like this you can see here, kind of what I'm talking about. It changes its angle with the use of actuators in the back, depending on the speed of the car or the driver braking to help it slow down. And so way back at the beginning of the year, when I was thinking about what I wanted to do for this project, I instantly knew I wanted to do something in the car realm, because I'm a big fan of cars. And so my interest in F1 kind of led into it. And so I just sort of decided I wanted to do a certain part of an F1 car, and that became the wing of an F1 car. And so I took that and I wanted to make it a little bit more personalized for myself, that I could use in my own car. And so that's where the active aero wing came from. And so with that, there's 4 main components to the project that I needed to do to bring this all to life. The first one being the wing profile, the shape of the wing. And pretty much it's pretty simple. This is the part of the wing, one of the most important parts, and this is what affects the drag and downforce that the wing has on the car. The next component were the mounts. This is pretty straightforward again. These are the parts that hold the wing to the trunk and just hold it up. We have the actuators. These are used all over the place in the world of engineering. This is specifically what sets this wing apart from regular wings. And these are what allows it to change its angles. It pushes the wing up and down. And then the last part here are the electronics, and these are pretty simple as well. These tell the wing and the actuators what to do and when. And so with all those parts together, I'm able to put them all together and bring this to life. And so at the beginning of the year, with my limited knowledge in the project, I got together a team of advisors to help me out. This is my expert advisor, Paul Winker. He was really helpful throughout the year. He has lots of experience in the engineering world, working as a designer for optomechanical systems for companies like Abegg, JDSU, and GE Lighting. And basically his role was to help guide me along the right path and just give me really good advice to help me on the engineering side of this project. And then I also had a group of these support advisors here to help me on the non-engineering side of the project. Despite that, I have my dad over there, who was a big help during the construction process. I have my mom, who was just good for emotional support, making sure to stay motivated. Both of them as well for financial support. I have my good friend, Ellis Wolub. He's a senior here at Grandview, good for emotional support. And same thing goes for my teacher here, who's my calculus teacher, Mr. Reyes. And yeah, just really good for help over the years. And so at the very beginning of the year, I came up with these 5 objectives that I wanted to complete by the end of the year. The first of which being earning my CSWE. This is another one of those certifications for SolidWorks. I wanted to become more comfortable programming and coding and things like that, because I know that that's going to be a big part of my future. I wanted to improve my design skills on SolidWorks, just 3D modeling in general, in terms of taking things from virtual on a computer and making them into a real product. I wanted to gain a better understanding of the design reasons behind cars and the aerodynamics of that. And then I wanted to become a lot better organized with such big projects and such a large scale. And so here's just a quick overview of my logo here. You can see it has my wing in it. It has certain colors that match up to the carbon fiber I use for this project. And then I also have included my initials in the name and in the picture there you can see that LA. And so one more part before I began this project, and that was to create a timeline to help me stay on track throughout the year. And so this is my initial timeline right here. I have 4 phases here: design, electronics, construction, and testing, and all that. And so with this timeline, I was planning to do very little research at the beginning of each phase, and then doing a lot of hands-on work, which is what would have been nice to do. But that ended up being not the case whatsoever, and I ended up doing a whole lot more research, especially in the electronics phase, than I intended to, and because of that, my construction phase and all that got pushed back about a month or so. And so with that, though, I was ready to begin my presentation. I was ready to get my project with the design research portion. And the first part, as I said, in the four components, was the main body of the wing. And so there's two different parts for this, which is the profile and material. On the left there, you can see a chart of these National Advisory Committee for Aeronautics. There's a bunch of profiles that they have that they've done research on. There's lots of statistics for them. And so I was looking for a profile that would make sense for the multiple positions that this wing would have, both at rest and while upright. And so this profile right here, the NACA 6512, was the perfect choice for that. I'll explain why in just a second. But for the main body, I also wanted to make sure that the material was sturdy and lightweight, and I wanted to make sure it also looked cool, because it's going on the car. Just before I explain why I chose this one, I just want to make sure these are clear. Lift lifts the car upwards, drag drags the car back, and downforce pushes the car down. And so knowing that, like I said, my profile needs to work well in both positions. And so when it's at rest, it needs to be maximizing its downforce to help the car get better traction and better steering. But I needed it to also maximize its drag while upright, so that way the car had maximum stopping power when it wanted to. And so this NACA 6512 ended up being the perfect profile for me, because at an angle of attack of less than 10, which is more at rest, it had low drag and high efficiency, which is basically the lift to drag ratio of the wing, in effect downforce. And then at a higher angle of attack, they had high drag and separation, both of which are pretty much drag, which is what I wanted. And so with this profile, I was able to get both the downforce and the drag in one. And so here's a quick visual representation of that. You can see on this left side, this is how the downforce works. So there's high pressure on top and low pressure on the bottom, which pushes the car to the ground. And then the difference over here is this big blue blob is this thing, is the separation. And with this, you can see that there's the pressure in the top and the front and the pressure in the back, and that difference in pressure causes pressure drag, which slows the car down. And so now that I knew which profile I was using and what the body of my wing was going to look like, I was ready to start designing it, and I used this in SolidWorks. And so, because I already knew the profile of my wing and what the shape was going to be like, I immediately got started on my mounts. These were my initial mounts way back at the beginning of the year, and which had three problems. Being that they would have taken a lot of time to create, a lot of money to create, and they also just didn't work whatsoever. You can see in the top there, where it would have connected to the wing, it really wouldn't have worked at all with how the wing changed its angle up and down. It would have been stuck in place. And so about halfway through the year, I went in and I redesigned them. So I split up the mounts into two different sections, being the actuators and the mount arms. And so with this, it was a lot cheaper, a lot faster, and I was also able to test different stroke lengths for the actuators. I was able to test different sizes for the mounts within this software. And then the last part of the design phase were the end plates here. The ends, which I thought would just kind of make it look nice, but they actually do have an added effect here. You can see on this left side here, there's a lot, it's a lot more dense. You might be able to see like a spiral effect in there. Whereas on this side, it's all really just flat, and yeah, you don't see the spiral there. And so basically what that means is that the end plates are decreasing the amount of pressure drag that would be acting on the wing without them. And so I chose these because they were more, they work better. And they also look better. So with that, I knew what my wing was going to look like. I knew, and then, yeah, so now I wanted to figure out how my wing was going to work. And so there's a bunch of different types of actuators. This is the parts that move the wing up and down. And so I don't know about y'all, but just looking at this, I was able to kind of decide which ones I was going to use. These two just would not work at all. They would, but this is the better option for me. Mainly because their size, these ones are very large and chunky. I don't need that. I need something that's nice and compact. And so that's what these had. They were also very easy to control, and they are very cost effective. So beyond that, I needed to figure out how I was going to control it. And so there was two paths I could have taken. The first of which being this kind of more electronic approach, which was to take either an Arduino or a motor controller, which pretty much just have the same use, plus an accelerometer. And basically what this would do is the Arduinos and the motor controllers would act as like a messenger to tell, these would be directly interacting with the wing to tell it what to do. And this accelerometer would be hooked up to the system to tell everything how fast it's going. And so this system would have worked great, but the only downside is that one, it required coding, which way back in the year I didn't want to do. And then it was also a lot more expensive, a lot more than Path 2, which was used my brake lights on my car. And so with this path, basically it sounds exactly what it sounds like. I'll hook up the actuators with the help of a relay to my brake lights so that when I would press down the brake lights, my wind would go up, and then I'd let off, and the wind would go back down. And so this is the approach that I did end up choosing. And so now that I knew how my wind was going to look and how it was going to work, I was ready to start building it. As I said, I wanted my material to be sturdy, lightweight, and look good. And so carbon fiber was the perfect choice for that. It's very lightweight, very tough, and super stylish. I think so. So there's a bunch of different ways that you can make carbon fiber parts. How about this right here? I thought was the most straightforward and easiest for me to do, which is called the carbon fiber layup method. Basically, you take this large mold of whatever part you're trying to make, you lay this carbon fiber cloth into the mold, which is what it is originally, and then you cover it in a coat of epoxy to make it, which is a glue-like substance that hardens once it dries. And so I thought I would just go ahead and take that approach. It was super simple. I went into SolidWorks. I was able to design this really simple mold. I thought everything was going great until I figured out that it would have taken around 2.5 weeks to print the entire thing. The wing's about 4 feet long. So that path just wasn't going to work for me at this point in the year. And so what I did is I talked to my advisor, and we came up with a solution, which was to kind of take that mold and turn it inside out. And so as you can see there, I have a styrofoam core / mold, which is what's in the wing right now. And what I was able to do with that is I took the carbon fiber, and instead of laying it into a mold, I was able to wrap it around this mold. And so that ended up being a whole lot faster, and it was also a ton messier. It was like winter wonderland in my garage there. And so despite not being able to get despite not being able to 3D print my molds for my wing, I was able to 3D print these end plates and caps, is what I call them now, because I extruded a little bit of the wing out of it. And basically that was so when I wrapped the carbon fiber around the mold, I'll be able to wrap it around these as well. And it'll all just kind of stick together as one system. And so now that I have my wing together and I have my end plates, I was able to wrap it all together now. This is just a quick little run through. Cut the carbon fiber, mix the epoxy, lay it onto the wing, the core, to make sure it all fits. Apply the epoxy. I used 3 layers of carbon fiber on both the top and the bottom. And then the last part was just let it sit. And then I also used this cloth-like material called Pure Ply, and I put it on there to make sure that the epoxy would set as an even coat and there wouldn't be any extra chunks sticking out. And so now that I had the entire kind of body set together, I was able to start on the mouse, which is the parts underneath. There's a bunch of different parts to these mounts that I have here. The tops there, you can see the U-brackets. These are what connect to the wing itself on the other side, kind of the anchor points. The U-channels down here is what would screw into a trunk. And then you have these 2 parts right here, the actuator on the back, which is what pushes the wing up and down, and then the mount arms, which support the rest of the wing. And so the main problem with these is that finding dimensions, finding parts with dimensions that I needed for this project with these U-channels and U-brackets was near impossible. I couldn't find the lengths that I needed, nor could I find the sizes that I needed to fit my my actuators. And so what I did is I took it upon myself. I went to Home Depot and I bought this massive, long, 8-foot pieces of aluminum. And I was able to just use a simple grinder, drill the hole I needed, cut them to size just as I needed. And it's the same thing for the mount arms. I was able to cut them, drill them, and then I also used a belt sander to round off the edges so the actuators have enough space to extend and retract. But then I also used the belt sander to create the angle that the wing is sitting at right now on the bottom edges of the mount arms, which is what it's resting on. So with everything put together and all, I was ready to start testing. It's just a pretty simple system right now. Just the two actuators, a 12-volt battery, and then a DPDT switch, which basically just has an up setting, off and down setting. And so you can see here, this is my initial test, not the best sound ever, but it very smoothly goes up and then it goes back down. And so that looked very nice. The only problem was that it was all upside down. So this is my very first test, trying it upright. And what I want you to focus on is this left mount here, the bottom of this left mount. And besides it sounds like it's dying, you can see right there, once it gets to the top, it kind of lifts up slightly. And when it goes back down, it sets back down to the ground. And so at the moment, it didn't seem like a big problem. I barely even noticed it, but it did end up being a big problem. Along with another thing was that the mounts were just very wobbly. And so you would pick the wing up and shake it and they would be all over the place, and you'd try to set it down. You'd have to set them all right. So I didn't want that. I wanted it to be nice and sturdy. And so the one fix I had for this was to use spacers. And initially I had these rubber grommets, and they didn't work very well. They didn't fit the space that I needed them to. And they were also, they're also rubber. So when the wing swings, so do they don't support it, they're not sturdy enough. And so my fix to this was to use these plastic balance spacers. And the great thing with these is that I was able to cut them down to the exact size that I needed to in order to fix that wobble. But not only did I do that, I was able to use this big piece of wood, as you can see now, to kind of act as a trunk lid so that everything would stay stuck in place. And so now that problem is fixed. It was not wobbling anymore at all. The only problem with this now is that before the wood, it wanted to lift up, and now it can't. And so what ended up happening is the entire thing broke. And it wouldn't go up, it wouldn't come down. Yeah, and then, so it actually ended up being a pretty easy fix. I wasn't sure what it was at first. I was thinking maybe it was the actuators, maybe it's sitting at. But it actually ended up being just the screw hole, the screw heads at the top. These are the screw heads that hold in the U-brackets. And what ended up happening is the top of these mount arms right here would run into these screw heads during activation. And so the entire system would break down. And this ended up being a super easy fix. I just used this Dremel right here, the same one that I used to cut down the spacers. And I was able to shave off a bit of the screw heads up there so that even if the mount arms ran into the screws during activation, they would still be able to fully extend and fully retract. And so with that, my entire wing was done. You can see it on my car there. It doesn't look the best. And despite not being able to actually get it attached to my car or using the electronics and the coding that I would have liked to, I know that I've learned a ton this past year. And I'm excited for what is to come in the future. And that's it. Thank you.
Is this something that you plan to continue in the future and actually have it permanently mounted on your car?
Yeah, probably not permanently because it's a little pretty much a DIY project. But whether it's continuing on this project or any other project, really, yes, I do really want to plan on still working on stuff like this, especially with the electronics and the Arduinos and stuff like that. Yeah.
What kind of mounting system would you do if you didn't have to screw it into your hood or your deck lid? What kind of mounting system would you use instead?
Yeah, so if I didn't want to screw it into my hood, I was planning on, or my trunk, I was planning on using electromagnets, which I would assume would work, but there was also slight, there was a little complications with that, but that's what I would use instead, yeah, some magnets, yeah.
Can you do interference checks in SolidWorks and have you model the screw heads? Did that give them a heads up?
Honestly, probably not. You can test for interference in SolidWorks, but the thing about one in SolidWorks, if anything is touching, it immediately breaks because it's all touching already. But also, it would have been probably a little more complicated than it needed to be. It would take a lot more to design it and test it and all that, so I maybe could have, but probably it's just taking a lot more time. Yeah.
How much would it cost roughly to get this more of like a permanent thing?
I mean, it could be permanent right now if you wanted it to be. I mean, I honestly probably, if I wanted to be permanent, I could make it right now. It ended up being around $350, which is really good. It was supposed to be around $500, so I cut down a lot on that. But it really just came down to me learning and stuff. The carbon fiber isn't perfect. But yeah, I mean, it could be permanent if you wanted to. I don't know. I can set up
So when you replaced your core for a styrofoam core, did that have any implications? Because
What was it? Sorry.
your core was originally meant to be, it wasn't meant to be what it was built to be. Like the core for your wing, it was meant to be carbon fiber, right? Like,
It was just a hollow, pretty much.
like when you replaced the material that you used to make your carbon fiber wing with the inside, did that have any lasting implications?
I don't think so. The styrofoam is pretty light to begin with, so, and the carbon fiber is enough to screw into, it's enough to hold on to everything. It's very sturdy. I mean, it's also very light. So whether I use the styrofoam mold or not, and I just used the 3D printed one, it would have still worked the exact same. I just would have had to find a different way to put it all together.